this problem from friction, and it is from previous year paper of Calcutta University 2022 and from the paper CC 10. And the problem is the condition for equilibrium of a particle constrained to rest on a rough curve under any given forces with usual notation is. 4 options are given. This is MCQ type problem, right? We already drawn in usual notation. This is x-axis, this is y-axis, and this is be any curve. And let the particle is constrained to rest on the rough curve. This is the rough curve under any given force. Okay. Let the particle rest or in equilibrium at the point P on the curve. And we draw a tangent at the point P. This is the tangent. Let it be mixed angle psi with positive x-axis. Okay, this is the positive direction of tangent and this is the normal. Okay, this is tangent and this is normal. And let the component of given forces in usual notation, the component of all given forces along x-axis is given by capital X, and component of all forces given along y-axis is capital Y, which are in usual notation. Okay, and in the normal direction we know that normal reaction act always. Okay, and if the particle move from upper side to lower side, then the friction force act along the tangent. That is, this is the friction force. Okay, and we use here the condition for equilibrium. Condition for equilibrium under the rough curve or under the friction force is given by mod F less equal to mu R. That is the numerical value of friction less equal to mu into R. And condition for limiting equilibrium, limiting equilibrium this is equal to mod F, this is equal to mu R. Okay, this is the condition of equilibrium and this is the condition of limiting equilibrium. Here we have to use this result. Okay, now we find all the forces along the tangent, that is T, and along the normal, that is along N. We get as, since this is psi, so this is also psi, and this is obviously pi by 2 minus psi. Okay, so along the tangent all the forces or the component of all the forces are given by, this is x cos psi along the tangent, this is y cos pi by 2 minus psi, sorry, this is minus psi, and this is friction force, this is equal to 0 because there are no other force along the tangent. And we write this equation as x cos psi plus y sin psi plus f, this is equal to 0, that is f, this is equal to minus of x cos psi plus y sin psi. This is equation number 1. Also along the normal, the component of forces are, this angle is pi by 2 plus psi, so along the normal we get x cos pi by 2 plus psi and plus this angle is obviously psi because this is pi by 2 and this is pi by 2 minus psi, so this is psi, and we get y cos psi, and this is the normal reaction, this is equal to 0. So we get R, this is equal to minus, sorry, this is already a minus sin psi, so we get x sin psi minus y cos psi. Okay, this is relation number 2. And we know that tan psi, this is equal to dy by dx. Okay, and if we take common from here cos psi, then we get minus cos psi into x plus y tan psi, that is minus cos psi into x plus y into dy dx. And from 2 we get, here also we taking common cos psi, that is x minus y, this is x tan psi minus y, so this is cos psi into x dy dx minus y. Okay, now putting the value of r and putting the value of f in the relation or in the condition of equilibrium, we get mod f whole square less equal to mu square into r square. So we get from here, we get cos square psi into x plus y dy dx whole square less equal to mu square into, this is r square, so we get, this is also a cos square psi into x dy dx minus y whole square. Okay, and since cos square psi, this is square, so we cancel out cos square psi from both sides because this is positive. So our condition is x plus y dy dx whole square less equal to mu square into x dy dx minus y whole square. And now we check, this condition is condition number 2. So our correct option is condition number 2 or option number 2. Okay, and if it is given that the condition of limiting equilibrium, then it must be equal. Okay, and so this is the condition of equilibrium, and if this is equal to, then this is the condition of limiting equilibrium. Okay, this is very, very simple and easy problem of MCQ type from CU 2022. Okay, thank you for watching.